Quantum gravity is a theory that attempts to explain gravity as a quantum field. It is based on the idea that gravity is mediated by a particle called the graviton. Welcome to my channel. Today we will discuss about the quantum gravity. Did you know that Albert Einstein was the first person to come up with the idea of a graviton? He did this in 1915. But he didn't know that it was a particle, because at that time quantum mechanics was not yet developed. It was only after the development of quantum mechanics that physicists started talking about the graviton as a real particle. Another fun fact is that the graviton is one of the most elusive particles in physics. It has never been detected directly, and we have no idea what it looks like or how to create one. Some physicists think that the graviton may not exist at all, but that gravity is actually a force that is transmitted by the curvature of spacetime. This is called the equivalence principle, and it was first proposed by Einstein in 1907. Now, let's move to our original topic. Right now, our universe runs on two very different sets of rules. First, there's general relativity, Einstein's masterpiece. It explains gravity, black holes, curved spacetime, the very fabric of the cosmos. But it works best when things are big, stars, planets, galaxies. Then there's quantum mechanics, the rule book for everything tiny, atoms, energy, particles, and forces. It's weird, random, and incredibly accurate, but it only works on very small scales. Here is problem. These two theories are brilliant on their own, but when you try to combine them, they don't agree. They speak different languages. Without a common language, we can't answer some of the universe's biggest questions. So one way to make sense of quantum gravity is to say that gravity gets stronger the smaller the object. Another way to make sense of quantum gravity is to say that gravity gets stronger the faster the object is moving. This is because the energy of a moving object depends on its mass and its velocity. So the faster you move, the more massive you are, and the more massive you are, the stronger gravity is. This means that if you could accelerate an atom to half the speed of light, then its gravitational pull would be twice as strong as it is at rest. In short, quantum gravity is the search for a single theory that unites the very big and the very small. A theory that treats gravity not as smooth space, but as something quantized, made of tiny units, just like light or matter. Imagine if spacetime itself was made of tiny threads or loops, constantly vibrating, changing, fluctuating. A quantum foam at the smallest possible scale. That's what theories like string theory and loop quantum gravity are trying to describe. In string theory, everything in the universe, particles, forces, even gravity, comes from tiny vibrating strings. In loop quantum gravity, spacetime isn't smooth, it's woven together from loops smaller than atoms. These are our best attempts at writing the ultimate law of the universe. But here's the thing, we haven't cracked it yet. Quantum gravity is still a mystery. We've never observed it directly. We have equations, but not the final answer. Yet solving it might be the key too. Understanding black holes, the Big Bang. Unifying all of physics into a single elegant theory. Somewhere out there, deep inside the fabric of reality, lies a hidden pattern that connects everything. And when we finally uncover it, we may finally understand what this universe really is. If you enjoyed this video, make sure to like, subscribe, and tell me in the comments. What do you think spacetime is really made of? Thanks for watching.